GayLussacs law helps us to determine changes in gases where we're looking at changes in the pressure and the temperature while our volume and number of moles are constant. So what we have is P1 over, nope, not V1. Okay. Get a few. P1 over T1 is going to be equal to P2 over T2. And if we were to look here, that as the temperature increases, our pressure is also going to increase, and we have a direct relationship. All right, so now let's take a look at what we're given in our problem. A gas has a pressure of 280 millimeters of mercury at 50 degrees Celsius. What is the pressure at standard temperature? We want to know the pressure at standard temperature. Well, remember, standard temperature is 0 degrees Celsius. That's not quite right, but we'll write it properly. 0 degrees Celsius, which is also 273 K. Remember, we cannot use Celsius in any of these problems. We have to always convert everything to kelvins. All right, so what is the pressure at standard temperature? We're given the standard temperature. Now we need to know what the pressure is. So let's write down what we have. P1 is equal to 281 millimeters of mercury. T1 is 50 degrees Celsius. P2 is what we're looking for, and T2 is equal to 0 degrees or 273 K. Let's go ahead and convert our T1 to kelvins by adding 273 to 50 to give us 323 kelvins. All right, so P1 equals, oh yes. So based on our relationship, what's going to happen? Well, our temperature decreases from 323 to 273. So our temperature is going down. And because we have a direct relationship, our pressure should also go down. All right, so now we've got P1 over V1 is equal to P2 over V2. And we're solving for P2. Okay, the question is asking what is the pressure at standard temperature. So we're given a pressure of 281 millimeters of mercury. So because we're using standard pressure and temperature, we have to be in atmospheres. So we need to convert this guy to atmospheres before we get started. All right? So P1, since I don't have any room up there, P1 is equal to 281 millimeters of mercury times 1 atmosphere over 760 millimeters of mercury. And that gives us a value of 0.370 atmospheres. I kept the 0 at the end so I can maintain my number of significant figures, the same number of sig figs. All right, so let's look at our equation. P1 over T1 is equal to P2 over T2. And we're looking for P2, so this guy is not so difficult. If we just multiply both sides by T2, then we end up with P2 as T2 times P1 all over T1. Now, we just plug and chug. So T2 is 273 kelvins. P1 is 0.370 atmospheres. And our T1 is equal to 323 kelvins. We know that our answer has to maintain those three significant figures. Remember, this 0 here is significant because it's after a decimal place. And when we plug and chug, we get 0.31. Oh, you know what? How many sig figs do we keep? Our original value was 50 degrees Celsius. So even though we have here 323 Kelvin, we always go back to our original values that were given to determine your sig figs. So we've got 0.31 atmospheres.